I'm Rahul from the Fun Robotics Network, and here with me is none other than Team Ro2D2 from Romania. They're year in and year out, they're one of the strongest teams in the world and currently hold the #1 OPR in the world, winning Alliance Captain at the Michiana Premier event, and their robot just has so much to learn from. Featuring their super fast active intake, their outtake that goes for both samples and specimens, they're hanging with pivots off the ground. I can't wait to learn more on Behind the Box. Hello Team Ro2D2, thank you so much for joining me here today. Now, let's just start with asking about, I know you guys are, at least in quals, you guys hit samples and specimens a lot, and you're one of the best at both. What makes you guys so good at both samples and specimens, and why do you guys choose to be more good at both rather than dueling or specializing in just one?
So it wasn't one of our requirements to be able to score both, because we knew that some alliances would like to score samples and some alliances would like to score specimens. And in order to do that, when we were designing the robot, we made sure that our robot can do both. And then after we've built it, we've decided that we need to practice both in order to assure that we're good or at least decent with a partner that we'd like to play the other type of scoring.
Nice. Okay, now the next thing I really want to get into is your drivetrain. I think you guys have one of the most compact robots, and that really helps you like align, speed around the field, get past other robots. Why don't we flip over your drivetrain? You can talk about your general drivetrain and how you're able to get it so small and what the exact dimensions are.
Yeah. So it's about 340 millimeters length and 316 wide. And we chose these dimensions because we wanted to implement the longest extension possible while remain in the regulations, and that's why we made our drivetrain shorter. And the designing process of putting everything together was a little bit complicated because we have to decide which components fit best where and how to optimize our center of gravity and the distribution of weight around the robot. But we eventually came up with this association, and we are very proud of it. We think it works very well, and we have very little balance when it comes to scoring samples, and we have our lift lifting.
Nice. Now let's just move on to your intake. I think it's really small, but it's super effective. Why don't you walk me through your counter roller, your intake design, what speed you're running at, and if we could run it with the controller too, that would be nice.
So this is our intake. We run on our intake, and as well as on our extendo motors and outing motors. We use Gobirla motors, which are 6,000 RPMs. And in order to do our ratios, we use GT2 belts, which are very efficient for high torque and high RPMs. And we have these very tiny pulleys right here that allow us to do whatever ratios you want. And right now, on the shaft, we have around 1,300 RPM on the intake. And after this GT2 belt, you have this transmission of HTD3 that goes to the header. And below the intake, we have an inverted round belt, which engages the counter roller. And this counter roller is custom made. We put silicone in a mold, and that's how we made it. And also, in order to optimize our transfer and detection of samples, in the intake, we have a distance sensor and a color sensor in these guides.
Nice. Now that's really cool. Now just touching on a couple of things. Why did you guys choose to go for a custom counter roller? Do you have any iterations, past designs, and what feedback do you have for teams trying to do something
in
similar?
The beginning, we use silicon tubes, just like this one, but with a different diameter. But we discovered that we can try many more durities of the silicone. And with that, we were able to try and add texture to it, and it worked better for us after we did that.
Nice. Now, touching on your horizontal slides, why don't we see, I think there's so much amazing packaging in the back. Can we see where those motors are mounted and how that's powered and all? So
the horizontal extension is powered by this motor right here below that has a transmission to this pulley right here. And then we engage it with this pulley that is placed here. And we also count each rotation with the wave encoder.
Nice. Now let's move on to your transfer and your outtake. I think you have a really light outtake size with that rail-based deposit. Why don't you just walk me into how that all works, your whole deposit system?
Yeah, so the transfer we just done, it's fully automated. That's why we have a color sensor, as my partner said. So when we collect from the submersible, we check the color of the sample. We also check if it's in the intake with the digital distance sensor. And then the horizontal extension retracts itself fully automated. And then if it's a yellow sample, the outtake goes to take the sample. using this extension, outtake extension. And if it's a color, a red or a color, depends on the alliance, we can just transfer it manually, because we can. It's very useful for scoring specimens, because when we play on the specimen side, we want to collect all the samples from the submersible and then go to the human player to give them the samples. And we do that only with our intake, because it's much more faster instead of using our outtake. And if we collect the opponent's color, the horizontal extension just doesn't retract.
Nice. Now, just touching on a couple of things. On your rail, I see you guys have counters from you, and just in general, why did you choose for this extending mechanism? Is it for specimens? How does it help you this year?
Yeah, so we have here a degree of freedom. Is a passive, so we don't have another servo using it. And it's very useful when we want to score specimens, especially in the autonomous period, because we have much more faster trajectories. Instead of diagonal strafe trajectory, we have horizontally trajectory. So when we want to score specimens, the outtake just extends like that, and we can just go diagonally on the chamber, because we won't affect the specimens. We also have this claw that can collect specimen from the clip, because on the nationals we had a problem because we took it from the sample, not from the clips, and we had the risk of unclipping the specimens when we want to score on the chamber. So we just wanted to be sure that it won't be a problem anymore.
Nice. Now, can we also see where the extension motors for these vertical slides are powered and how the entire system is packaged back here?
Yeah.
The outtake motors are right here. There are two bell motors, and we have a transmission that goes to around 1,280 RPM.
Nice. Now, another thing on the back of the robot, I see you guys have these sprung arms. How do you use them in your game?
There are our guides for collecting specimens from the wars, and we use them as this. We put the forward in this back position, and they help us align to the specimen we are collecting them.
And did you always have them sprung from the start, or were they passive and you later made them sprung?
Yeah, we did them from the start because we knew that when hanging, this would be a problem because they wouldn't allow us to pass the bar, and that's why we made them retractable in order to compact when we are racing for the second bar.
Now let's just get into your hang. I think it's really cool how you guys are able to pivot off the ground and able to hang. Let's go everything from that pivot off the ground to the PTO to your hooks. Let's just break down the system.
Yeah. So we have this, we call it a ZAC actually, and we use two Action Maxis mounted in the drivetrains that action this jack using an over-center ring case because we wanted to protect the servos and lock it in a position where it won't move and won't use power, and that's why we did it over-center. And after the robot is tilted, we engage our PTO system, which is spring-loaded. We have a servo that keeps the couples locked, and then we enable it, then being spring-loaded, they just engage and connect to the rear drivetrain motors, and that's how we hang with 4 motors, having enough torque to do that. And then we just, with the outtake, grab on the first bar, then we retract, use these passive hooks in order to lock ourselves to the bar, and then we reach to the second and do the same thing.
Nice. Now, just a couple things on the hang. Did you guys have this pivot system from the start of the season, or how was it developed throughout the year?
This is actually our second robot that we've developed this season. And for the first one, we wanted to focus on the intake and outtake system, and we canceled the making of an hang. And eventually, when we reached that point, when we were happy with our intake and outtake and we wanted to implement a hang, we decided that we couldn't adapt that robot in order to do the hang, so we did this second one.
Okay, nice. Now, on terms of just overall how your robot works together, there's so many moving parts here. How do you guys use software to sort of tie this all together? I know you guys talked about current sensing, and what other sensors do you guys have on your robot?
Well, apart from the sensor from the intake system, we have a distance sensor over here to see when we are close to the specimen, so we can grab them automatically. We use a pinpoint with two go-bit odometry modules to track the position of the robot, and we also have a limelight camera to detect the samples from the submersible for the autonomous period.
Nice. Now, just one last thing I think we haven't touched on is I see you guys have counterswung your slides with bungee cord. Why don't you talk to me how that works in your general slide inserts? I see they're aluminum, or how has that helped,
no.
or polycarbonate? How has that been for you guys this year?
So the inserts are polycarbonate. They were very good for the whole season. We didn't have any problems with them. But instead of the caps, the holding caps are made out of aluminium because they were breaking a lot. So we decided to remove that problem and do it with aluminium metal. I think it's a 1.5 millimeters thickness. And this is a bungee cord. It's cascading and it helps for the weight of the outtake. When we want to lift the outtake, the weight it's much more easier with bungee cord. So it helps the two motors to lift up in 0.7 seconds. And we have on both sides, on the front and also in the back, for equally balancing the outtake. We also have, when we want to hang, these spring locks. Because we had a problem last season when we wanted to hang. Our springs were pulled very hard and they broke. So we implemented this lock system in order to not damage the springs anymore.
All right, thank you so much, Ro2D2. I think you guys have an amazing season. #1 ranked OPR, winning the Michiana as the winning alliance captain. Thank you so much for being here today. Catch me next time on Behind the Box.